So at the end of the day yesterday, we went over a question very much like this one. It was about a bus that traveled north and then traveled south, and we found the average velocity and average speed of the bus over the entire trip. So, as a bit of a refresher from yesterday, I want you guys to try this question. It's a rabbit. You can imagine a little bunny running around. Don't think about why it's running. Not being chased or anything. Okay, but we want to figure out what the average speed and average velocities are, okay, for this rabbit for this trip. Okay, so give it a few minutes to try that. Write the whole question down. Okay, set it up, part 1, part 2 in totals, okay, and see how you do there. Okay, so if we're looking for average speed and average velocity, is what we do to calculate those things fairly similar most of the way through. Yeah, there's really only one small difference, and it's basically right at the end. Okay, one of them cares whether I go west or east, and that one is velocity because it's vector. Okay, and one of them doesn't, speed, it's scalar. All right. So the first thing I want to do is simply put in here, okay, all of the givens that the question has told me. All right. So in part 1. Right, the rabbit is running at 22 meters per second east. And it does that for 12 seconds. In part 2, okay, it turns around and runs due west at 17 meters per second for 32 meters. Now we're looking for the average speed. So I've got my givens for part 1, I've got my givens for part 2, and I should probably look at having my totals over here. Okay, now if I want to calculate either average speed or average velocity, what two things do I need? Right, for speed, I need the total distance and the total time. And what do I need for average velocity? Total displacement and total time. Okay, so I don't have the displacement for part 1, which makes it hard to get the total displacement. And I don't have the time for part 2, which makes it difficult to get the total time. Can I get those two things that I'm missing? Yeah. It just means I have to do some intermediate calculations. Okay? If I don't know what D is for part 1, that's fine. I can calculate it because I know that B equals D over T. And I just need to solve for D. So I'm going to multiply both sides by T. Okay, and I'm going to have 22 times 12. And that will give me my displacement. Right? For part 2, if I want to find the total time, same thing. Velocity is displacement divided by time. If I want to solve for time, I'm going to multiply both sides by T, divide both sides by V. Okay, so T will equal D over V. All right, so on this one here, we're going to have 22 times 12. All right, so it's going to go 264 meters. What am I missing? Nope. East. Yeah, east. Okay, that would be my direction, right? I need to know because displacement has direction. Okay, and then for this one here, I'm going to have D displacement over V, so that's going to be 32 over 17, so that's going to be like slightly less than 2. Okay, so 32 divided by 17, 1.88 seconds. All right, now do I have enough information to get my total displacement, total time, and total distance? So let's look at speed first. If I want to find my total distance, what do I have to do? Add them together. Add what do I add together?
Two distances.
The two displacements, but I'm just going to make them both.
Distance.
Yeah, I'm just not going to put any direction on them because direction doesn't matter for distance. So I'm going to take my 264 and I'm going to add it to my 32. All right, so that's going to be 296 meters, I think. I probably shouldn't do math in my head. Okay, and then I got to do the total time. Okay, 12 seconds and 1.88 seconds. Okay, everybody with me on what I did there? Just total distance over total time. All right, so that's going to mean then that my average speed is 296 divided by 13.88. All right, so the average speed of the rabbit is 21 meters per second. Do I need a direction on that? No. No, speed is scalar, okay? That's just how fast it went in the course of going both west and east. Okay, now, what's the only thing I do different for finding velocity?
You have to subtract the distances.
Right, I have to, or add them and make one of them negative, as long as I put in that these are opposite. Okay, one is east and one is west. The most likely way is to subtract. Okay, I'm going to have my 264 meters, that's east, minus the 32 meters west. Okay, is my time still going to be 13.88? Yeah, that doesn't change, right? I didn't go back in time because I went west. Okay, so I'm going to have 232 meters east divided by 13.8. Okay, so my velocity is going to be 17 meters per second. What am I missing? Direction, which is? Okay, this is a tricky one. I went 264 meters east. I came back 32 meters west. Do I still end up east of where I started? So my velocity then is east. Okay, my displacement is 232 meters east. Therefore, my velocity is 17 meters per second east. Okay, your displacement and your velocity will always share a direction. Okay. All right. Now, why didn't I write any decimals on my answers? It's a little something called significant digits. Okay? It's something that we use in science to make sure that any math we do doesn't change the accuracy of any measured values we did the math with. Okay? So I can't have something that's measured to the nearest hundredth and add it to something that's measured to the nearest thousandth and then say, oh, my answer is accurate to the nearest thousandth. It's not. It can't be. One of my numbers wasn't measured that accurately, so my answer can only be as accurate as my least accurate measured value. Okay? And so in this case, because I did a lot of stuff, okay, my least accurate numbers all have what we call two significant digits, that is two measured values. Okay, so my answer can only have two measured values. Okay, we don't do a lot with that in Science 10, but I'll bring it up from time to time just in case you ever wonder why I didn't write down a lot of decimals. Okay. All right, any questions on how that one worked? Okay, that is a very typical B equals D over T question for Science 10. Okay. So just quick review here. Remember that scalar quantities have magnitude only. Speed, distance, mass is a scalar quantity. Okay, time is a scalar quantity, right? What about weight? Mass is a scalar quantity. Is weight a scalar quantity? Are mass and weight the same thing? It's okay if right now you think they are. Okay, it's another one of those things we totally messed up, okay, in North American society. Weight and mass are actually not the same thing. Okay, mass is how much of you there is. It's what we typically call weight. Okay, weight is actually the force of gravity acting on your mass. It's actually not measured in kilograms. It's a force. It's why you would feel somebody's weight if they sat on you. Okay. You don't feel their mass, you feel gravity pulling them down, squishing you, okay? So weight and mass are actually two different things, okay? It's actually kind of fun because whenever somebody asks me how much I weigh, I tell them what I weigh, 785 newtons. And then they kind of chuckle awkwardly and find someone else to talk to. Okay, which is totally fine with me because I'm not a very social person. Okay, so it's also really rude to ask somebody that question, and this is kind of my way of going, are you kidding me? How rude. So I tell them what I actually weigh. They have no idea what that number means, okay, because I didn't tell them how many kilograms or pounds I am. Okay, they didn't ask me what my mass was. So you can do that to somebody. Take your mass in kilograms, multiply it by 9.81, there's your weight. Next time someone asks you how much you weigh, tell them. And then hopefully they'll understand just how rude that really is. Okay? So mass, weight, two different things. So if you're going on a diet, you're not trying to lose weight. You're trying to lose mass. Okay? You're trying to make less of you. Okay? Or if you're going to hit the gym, put on some weight, you're trying to make more mass, not more weight. If I want to be heavier or lighter, I just got to go somewhere else. Okay? How much I weigh is based on where I am. If I go down to the equator at sea level, I will weigh less than I weigh here. And there won't be any less of me. Okay? And that's because the pull of gravity is actually less at the equator than it is here. Because you're actually farther from the center of the Earth at the equator than you are here. Because while the Earth is round, it's round. Okay? It's not perfectly round. That doesn't mean it's flat or a donut or any of those other crazy ideas that are out there. Okay, but it isn't also perfectly round. It's actually, this is a hyper exaggeration. It's not a football, but it's not a basketball. It's kind of like they took a basketball and squished it a little bit. Okay, so you're actually, when you're standing at sea level at the equator, further away from the center of the Earth than you are at the pole, so you actually weigh less.
If you have a higher, if we're up here, does that affect how tall you are too, or?
Yes, to a small extent. Yeah, I mean, because you always hear, right, if people go to the International Space Station, they get taller. Yeah, and that's because gravity's not compressing your spine or your joints, so you actually get taller. It's more that your joints get loose. But yeah, you're going to be a little bit taller in space, or where there's a little bit less gravity. Okay, there's actually been some studies of how often Olympic and world records are broken at near the equator than further away. Okay? There's typically more records broken when the Olympics are held near the equator because everybody's just a little bit lighter. Okay, at the equator. All right, and then for vector quantities, come on. Okay, they have both magnitude and direction, so displacement, velocity, okay, force, acceleration, okay, all of those things are vector quantities, okay, for that. Okay, these are a couple of easy ones, way easier than the one we just did. Give this one a try. All right, so as always, guys, we just want to write down what we're given. Okay, runs 100 meters. Was that a distance or a displacement? It's a distance. They don't tell me the direction. Okay, and does so in 20 seconds. That would be time. Okay, how fast is it going? Looking for speed, so no arrow over top of the V. Okay, no manipulation required on this one. Okay, simply 100 divided by 20, and that's going to be 5 meters per second. Okay, everybody all right with that one? You will never get one that easy from me. Okay, let's try this one. Like the one we started with. Okay, elevator traveling up and down. Looking for average speed and average velocity. All right, so on this one here, okay, again, we want to write down our givens, and we want to write them down according to the parts of the trick. Okay, so in part 1, okay, the elevator is going to go up 85 meters, so that's a displacement. Okay, and it's going to do that in 30 seconds. And then in part 2, it's going to go down, and it's going to go down 60 meters in 20 seconds. Okay, and now we're being asked to find average speed and average velocity. Is this easier than the one we did at the beginning? Because there's no what? What did we have to do on that other one we don't have to do here? Yeah, we don't have to do any intermediate calculations here, right? We know D and T for both parts, so that makes this one quite a bit faster. Okay, so our totals, okay, are as follows. Our total distance is going to be how far? 145 meters. Right, just add them together. It doesn't matter whether they're up or down. Okay, and my total displacement, I go 85 up and 60 down. What's my total displacement?
25
25
meters. Seconds.
meters
Oh.
up, right? Sorry, I just thought about how confusing that sign was. Like maybe you thought I meant a bigger number. Yeah, direction up. Yeah, you got it though. Okay, time. What do I do with the times?
Add them.
Just add them together, right? 50 seconds. All right, so now that I've got those, now I can calculate my average velocity and my average speed. So my average speed will be my total distance divided by my total time, 145 divided by 50 seconds. Okay, it's 2.9 meters per second. And to get my velocity, it's just going to be 25 divided by 50, so 0.5 meters per second up. Okay, would you lose a mark if you didn't say up? Yeah. Okay, because then it's a speed, not a velocity. Okay, all right, how are we feeling about this stuff? Okay, like the math's not too hard, right? Okay, it's mostly going to be as I make the questions more complex in terms of the context and the reading part. Okay, that's what makes these more difficult. The math doesn't really get any harder. Okay, we move into other equations that might be a little more complex, but it's just algebra. Okay, once you got the hang of the algebra, it doesn't really matter what formula I throw at you, no matter how complex, you'll be able to move it around because you'll know the rules of algebra. Okay. All right, try this one. 3 parts. Elephants. I don't know why I picked elephants. Just elephants, okay? Now, in this one here, there is something that we haven't done yet that we have to be mindful of. I'm giving you time in hours, velocities in meters per second, okay, and distances in kilometers. What should I do with my units? Convert them. I should make them all the same. I need to pick 1 unit for distance. I need to pick 1 unit for time. The best way to do that is to look at what the units for your velocities are and make your distances and time match that. Okay, so what should I convert the kilometers to? Meters. What should I convert the hours to? Seconds. How many seconds in an hour? 3,600, yeah, okay, 60 minutes times 60 seconds, 3,600. Okay, so make those conversions, right? How many meters in a kilometer? 1,000. Kilo means 1,000. Okay, doesn't matter whether it's kilograms, kilometers, kiloliters, it's 1,000. Okay, that's what kilo stands for. All right, so make those conversions before you do anything else. So as you're writing down your givens, convert the units and then go from there. Okay, so the first thing we said that we needed to do here, okay, is that we need to, when we write down our givens, we need to convert our units, okay, so that they all match what the units are in our velocity. Because it's much easier to convert the units for singular things like time and distance than it is to convert units for something that's compound, like velocity, that has meters and seconds, and I would have to change them both, okay? So, we got part 1, part 2, and part 3 here, right? All right, in part 1, the elephants walked for 1.1 hours. All right, I need to convert that 1.1 hours to seconds. So 1.1 times the number of seconds in an hour, 3,600. Gives me 3,960 seconds. All right, so I've converted my seconds now, or my hours now to seconds, right? And it says that they walk at 3 meters per second north. Okay, and that's all they give me for part 1. In part 2, they walk 7 kilometers south. Okay, I need to convert 7 kilometers to meters. How many meters in a kilometer? 1,000. So how many meters in 7 kilometers? 7,000. Meters, and that is 7. Right, and they do that in 1.5 hours. That should be 5,400 seconds, yes? And 3,600 times 1.5 is 5,400 seconds. Okay, and then in part 3, they walk at 4.5 meters per second north. For another 2 hours. Okay, well, 2 times 3,600 should be 7,200 seconds. All right, now everything is in meters and seconds. If I want to calculate the overall distance traveled and average velocity, okay, I first need the distance for all 3 parts. Do I have that? No. So I've got to calculate that first. All right. So in part 1, I know V and I know T. So V equals D over T. Okay, and I'm solving for D, so I'm going to multiply both sides by T. So I'll have 3 times 3,960. Okay, so they're going to go 11,880 meters in part 1. And that's north. Okay, because they were walking at a speed that was, or sorry, a velocity that was north, that means their displacement is north. Okay, so now I've got all 3 things for part 1. I don't need to calculate velocity for part 2. I already have d and t, so I'm good there. Okay, part 3, I also don't have the distance, or the displacement, sorry, it's the same calculation, v times t, so it'll be 7,200 times 4.5. All right, 32,400 meters. And that's north. Okay. Can I calculate the total distance walked by the elephants? What do I do with the 3 Ds? Add them together. I don't care that some are north and some are south. I simply add them together because distance is scalar. All right, so I take my 32,400 and I add that to 7,000 and add that to 11,880. All right, so they walk a total distance of 51,280 meters. Can I use that number for the next part? I cannot. That is a scalar quantity. It's distance. They want velocity. Okay? Average velocity is total displacement divided by total time. So now direction matters, at least for the displacement. Okay? So I go 11,880 meters north, 7,000 meters south, and 32,400 meters north. Okay? So when I do my math to get my total displacement, what's it going to look like?
You go add the two norths together and then subtract south.
Exactly. Okay? Or I add them all together and I make south negative. Okay? But I have to reflect that one of these things is taking away from the other. Right? There are two sections where they go north and one section where they go south. Okay? So I simply have to reflect that in my math. So instead of doing what I did here, okay, I'll take my 32,400, I'll subtract 7,000, and I'll add 11,880. Those are the two that are north, that's the one that's south. All right, my total displacement then is 37,280 meters north. What do I do to get my total time?
You add it all together.
Add it all together. Okay, so I'll take my 3,960 plus 5,400 plus 7,200. All right, there's my total time, 16,560 seconds. Okay, now I can get my average velocity. I simply divide those two things. Okay, so the average velocity of the elements is 2.25, actually, sorry, 2.3 meters per second north. Okay, that one is about as involved as you would ever get. Okay, it made you do quite a bit of stuff. You had to do 2 intermediate calculations, 2 final calculations, and several unit conversions. Okay, now, unit conversions are going to be very commonplace in physics. You will very regularly have to convert hours to seconds, seconds to hours, meters to kilometers, kilometers to meters. It's going to happen all the time. Okay, so just know that there's 3,600 seconds in an hour, and there are 1,000 meters in a kilometer. Okay, these are things that should be kind of automatic at this point. You've grown up in the metric system. Okay, you're lucky that you grew up in the metric system, because you don't have to remember that there are 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile, or yards in a mile, feet in a mile, whatever it is. It's stupid, okay? Like the imperial system, you have to remember all these numbers in order to convert from one thing to another, okay? In the metric system, everything's the same, okay? There's the base units, grams, meters, liters, okay, pascals, whatever, and then we use the same prefixes for everything. Kilo always means 1,000. Okay, centi always means 100. Milli always means 1,000. Okay, deci always means a tenth. Deca always means 10. Okay, so it's always the same. So you're fortunate you grew up in the metric system, even if you don't think so. Okay, because it's way easier to do all the conversions. All right, any other questions on that one? What do you suppose your quiz will be on tomorrow? Yeah, there's going to be a couple of V equals G over T kind of questions for you to have a look at tomorrow. Okay, we got 10 minutes left in class here. What else have I got? Okay, in your Google Classroom, in the classwork tab, and we haven't had to do this for a while, but down here in course materials, worksheets, other stuff, okay, in there is your physics workbook, okay? So you're going to want that open. And I would like you guys to try number 4 and number 5. 4 and 5. I'll make that a little bit bigger in case you're actually using mine. Okay, so 4 and 5. Okay, so for number 4, in part 1, okay, we know that the bus travels 11,000 meters. Why did I convert it to meters? It was in kilometers, and what was my velocity in? Meters per second. I needed to make the units match. Okay, so we're looking at 21 meters per second. Now, actually, this question is worded really badly. Why is it worded really badly? Does it ever tell me what direction that 21 meters per second is? Then it's not a velocity, is it? Okay. All right, so I've got a distance and a speed, okay, and I have the same thing for part 2. It's only 1 kilometer, which is 1,000 meters, and the speed for that part is 4.2 meters per second. All right, if I want to calculate the average velocity of the bus for the entire trip, okay, it would actually be average speed because I have no idea what direction anything is going. I need total distance and total time. Total distance is right there. It's 12,000 meters, okay? Do I have the time for either part? Can I get it? Okay, same as we always do, T equals D over V, so that'll be 11,000 divided by 21, and on this one, it'll be 1,000 divided by 4.2. All right, so 523.8. Okay, and then for this one here, 1,000 divided by 4.2. Okay, 238. Right, now I can get my total distance, total time, and get my average velocity. All right, so tomorrow expect something like that in your quiz. I'll post it later on today. If you're having trouble with this and you'd like to come in and see me for some help, I'm around at lunch, nighttime, after school for a little bit. Totally up to you.